today's topic is fairly like you should be able to get it even without much of this previous knowledge. But all of our lectures on these topics are recorded, so so that should do you good, I think. And then cool. So I think without further ado, let's just get started. Since there are so many people late, it's a good thing we record the lecture. But yeah, can't wait longer than 7 minutes. So yeah, today we would learn about methods. We would revise some of the discussion of repetition structures that we've had, and we'll also go over a thing called recursion and perhaps error handling, but we probably wouldn't get there this week. And at the end of these topics, that would be the end of chapter 1. And then we can get into the grit of the course. So the course starts by covering like core programming knowledge. So like the basics of how to program, and then it gets into more higher abstract concepts. So, but yeah, this is actually a good place to become introduced to programming is methods, which is what the first thing we would cover it today. And I like to start discussion of methods with a discussion of functions, because people are more familiar with these, although some people are intimidated by when there's letters in maths, but I don't know. I do think this is a good place to start. Let me just do this. So in maths, we have this idea of a function. So a function might look something like this, like b equals a squared. And it is literally this simple. And in programming, we try to keep functions quite simple. Like each one will do a really small, simple task. So in this case, we would say like b is dependent on a. B is dependent on a. So if a is 3, then b is 9, right? 3 times 3. So that's all that function is saying. And yeah, we could do a fairly similar thing in methods. If the students who had attended the previous lecture would see that, would also know that computers need types. So it would have to be more explicit than this. So I'd have to tell the computer b is an integer and a is an integer. I would have to tell the computer that extra information. But in a computer, methods are very similar to this idea of functions that we have in maths. Another way of writing this would be like fa equals a squared. So all this is acknowledging is that b is actually not serving a useful purpose here. We don't really need b. I can just replace b by saying f of a. So that is to say, b is just something that is dependent on a, right? So you don't need to explicitly say what b is if you already know what a is. Okay, because for example, you could say f of 3 equals 3 squared. So that's just saying like, instead of b, you would just write f of 3. And the same, you could do f of 9 equals 81. So that's just to say 9 times 9, of course, is just 81. So I know this is a bit heavy to start off the morning, but you can also do it like this in a nested way. So f of 3, because we know f of 3 is 9, right? Because 3 times 3. And so f of 3 becomes f of 9, which we know is 81. So f of 3 is 81. Okay, so that's just a revision of functions, and that is really as deeply as you have to understand functions. In computers, we would use something called a method, but it actually ends up being very similar. So to start off our understanding of methods, we're going to program this exact mathematical function inside a C# method. So before that, we should discuss the sort of template of what a C# method looks like. Okay, I see we've got some extra people joining. That's cool. Maybe we can do the quiz on the break. I don't know, because I do like doing it to prepare people for the tests. Okay, so this is sort of what a C# method will look like. So we have these 2 words. We can just ignore for now. They are a part of the next chapter. Forgive my drawing. It's terrible with the trackpad. I do have a mouse here. So let me try with that. Let's see, is that better? Okay, no, not really. So cool. So yeah, ignore the words public and static for now. What matters to us currently is really like type and name, type name, return variable. Okay, so where it says type, this is just your sort of standard C# type. So actually I can remind, because even people who have been at the previous lectures would probably need a reminder on this. So let me go open that slide. Okay, but you can also see it on page 9 of the PDF, I think it is. Yeah, page 9 of the PDF has a whole list of types at the top of it. But there is a fairly nice one in this slide. So here are all the types that are relevant to us. So short, int, long, float, double, char, string, and bool. So bool is for Boolean, just means true or false. So like 1 or 0, basically. So where these words type are, you can replace the word type with any of these. Okay. So what it signifies is sort of like, okay, so I'll go through each one. So this type here is to say what the type of A is, quite simply. So that's all that first word type does. And we can see that A in this case is an integer, but in a computer's mathematical function, we could also pass in like a word, or if we want to pass in a number with a decimal place, it would be a double, things like that. So this first type shows what the type of A will be. Name is literally just saying what we are going to call A. So in our case, we'll call A, the name will be A. So this would be like int A, because we're passing in an integer. So just a number anywhere, any negative or positive number without decimal places, we're passing in an integer. So type will be replaced with int. Name will be replaced with A, because that's the variable that we're passing in. So that's what's in the brackets there. That's explaining that. The name on the outside here, this name, is the name of the function. So our function was called f. So our name there would be something like f. You probably wouldn't make a method's name one letter just because it's bad practice. So in programming, you'll usually make the method name explanatory. So it explains what the method will do. And then this last type here, this type, is saying the type of the entire returns of what the function will give back. So this function gives back A times A. Because A is an integer, A times A will also be an integer. But yeah, basically the type, this denotes the type that the method has. So will the method return a word? Will it return a number? Will it return a number with a decimal place, etc.? It could return many, many different things. So that isn't, this introduction would of course make sense to someone who had seen all of the previous contents more, but maybe when you see it in code, it might help as well. So next, the word return, we'll start understanding this more once we start playing with the code more. But the word return, you should also understand if you've been practicing the Code Wars katas. I don't know if, I know I've seen on the clan that quite a few people have finished some of the katas. So return just means what you give back. So you're basically just telling the computer, okay, I'm finished doing whatever this method does, and this is my response. So when I say return variable, so I'm saying that variable is what I'm giving back to the computer. So we tell the computer to call the function f on A. We say A times A, and then we return our answer, right? So we return A times A, because in this case, that's our response. So to see what this would look like in full C# code, right? So right here is our function. So this is us programming f of A, just in the circle here. So yeah, I think I'll go through exactly what this is doing so that people can understand better. So we start running always. We have a thing called the main method, right? The main method. Any C# code will have this, and that's where the computer will start running. Okay, so we start there. So we begin in the main method, and cool. So we start on the first line of the main method. This is the first bit that the computer runs. Int x equals 3. So this is just saying we're creating a variable. Its name is x and its value is 3. Okay, its name is x and its value is 3. And it's an integer. And we can see it's an integer because it's just 3. It has no decimal places. So that is what we call an integer. Okay. We then say, so after we run that line, it updates the computer's memory. Whenever we say x, the computer will now think 3. So x has just become a placeholder for the number 3. We then go to this next line, console.writeLine function x. I think there is a nicer, yeah, there is. Let me try using that. So after we run the first line, we then come to the second line, console.writeLine function x. So this is, it's fairly simple. It looks like a long line that's horrible to understand, but it's quite simple actually. So this first bit, the console.writeLine x, this is just saying, okay, computer, print out to the screen. So I actually, just to remind those who forgot and for those who are here for the first time, because I do see there were quite a few people added to the group on that first day, on yesterday, I mean. So let me actually just show that in Rex Tester. So I'll also post this in the chat. So chat. This is where we have been programming. I could start having power issues, but only around. Oh, is it load shedding again? Is that what's going on? That would make sense if other people are having power issues or something, because it is a bit strange that attendance is so low today. Oh, okay. If that's what's going on, that makes more sense. Okay. Oh, okay. So other people have load shedding as well. All right. That's okay. That makes sense. Sorry, I didn't know that because there's none scheduled in my area. It could just be that there was substation problems because there have been quite a few lately, hey? Okay, well, the lecture will be recorded as usual. So yeah, next time, obviously, we'll have to work around these. Like we can maybe schedule the lecture for a different time or something. But yeah, sorry about that. I didn't know. Okay. Anyway, so, but this provides a good time then for people to catch up. So console.writeLine, let me just explain this little method here. So whatever I put in these brackets, the computer will just print out to the screen. So let's see what that means. When I run this code by clicking run it, this prints out Saturday because I say console.writeLine and whatever I put in the brackets will be printed out to the screen. So if I want to print out the number 9, it prints out 9. If I want to print out 9 times 9, this will now print out 81. So you can see this literally just prints out things to the screen. So fairly simple idea there. Console.writeLine. So we're just saying, okay, computer, print out function X. Now that won't actually print out the word function and X. This is calling our method. Okay, so you can see function X. The word function currently has a meaning. When the computer sees function, it will go over here and it will check out our method because our method's name is also function. Okay, so if you recall, we have to give the method a name. right? We had like public static type name, and then returning something. Okay, so let's continue going through this. So we know what console write line does now. It prints out whatever we give it. So in this case, we gave it function X, and the computer sees the word function and it thinks about this function over here. So we have, cool. So let's continue thinking about this. So the computer sees function and it goes and looks for, it doesn't know what function means. So it goes and looks for a method called function, and it will find it in this case because we created the method function. Okay, so what happens now? So the computer sees that function exists. As soon as it sees this definition of function, the first thing it'll see is int, right? We're ignoring the words static and public. We'll see what those mean later on. So it sees the word int. Makes sense? So what this is saying is the result of this. So the result of calling function X, the thing I get back, we know it will be a or an integer times an integer, right? Because we're creating this function over here, fa equals a squared. So this function X is going to give back like an a squared, right? It's going to give us back the something raised to the power of 2, which is just an integer. So it's giving back an integer. So this is just telling the computer what to expect. And the computer always needs to know that, right? Before it does something, it needs to know like, okay, when I'm finished doing this thing, what will the result look like? Because it needs to know how to handle that result. So we're telling the computer here, when you get back the result of function X, you're going to get back an integer. Okay. The next thing it sees is obviously the name of the function so that it knows where to look when we write function. So it will associate the word function with our method here. And the next thing it sees is int a. So this is telling the computer what the function expects. Okay. So when we call function, it expects us to give it an integer. Okay. So we do give it an integer, right? We give it x, right? And we can see that x is an integer. On this first line, we said int x equals 3. So the function expects us to give it an integer, and inside the function, it will call that integer a. Inside the function, that integer will be called a. Okay. And then from then on, I think once you've got that sort of flow down, so we call function, we give it x. X is a placeholder for 3. X is a placeholder for 3 because on the first line we created x and set it to 3. So that x goes over to function. We then go to the first line of function. It happens to be the case that there is only one line here. So we go to the first line of function. It says return a times a. Okay, so a is set to 3 because we give it x. So we give it an integer. Here it's called x. In the function, it's called a. And it says return a times a, which is just right. It becomes x times x basically, which is 3 times 3. So that's 9. And so this function x bit over here is just replaced with the number 9. Okay, and so then this becomes console.writeLine 9, and it'll print out 9 to the screen. Okay, I know I explained that in probably almost too much detail, because understanding like every step the computer takes probably isn't necessary. If you see the whole flow, I think it should make sense. So what I want to do is just go over to RexTester and program this up, and we'll see how that goes. It's a real pity about this load shedding thing. But I'll maybe open a poll on the group and ask if people want the lecture redone or something. I don't know. But we do have quite a tight schedule, unfortunately. Okay, so we write public static. We're ignoring these words for now. They don't matter to us. Okay, we are creating a function. It is going to return something. So I'll literally write it up how we had the template, okay? We have to give the function a name. So this will be our function name. Okay. we'll say the type that the function takes in, or I'll call it expected type, and the name of the thing that we expect, and then we're going to return something of type. Okay, I'm explaining it a lot, so just so that it's clear exactly what we're doing, because I don't want to have to explain methods too much again. I have a problem joining the Zoom meeting. Mine says I must enter a meeting password. Interesting. Okay, so how do we correct that? Video settings, audio settings will probably be. Yo, lots of problems today. Did you guys have to enter a meeting password? I think maybe this person's trying to use the meeting ID. Let me maybe suggest that they open it in WhatsApp web. Try opening. Did anyone else have this problem? Did you guys have to type a password or something?
No, sir. Maybe they should try leaving it blank and then just going through.
Leaving it, excuse me?
If you leave it blank when there isn't a password, it should work.
Yeah, I think it is currently blank. I mean, I didn't change it, that's for sure. Let me see. Where do I see like these meeting settings? Today is not going too smoothly. Problem. Okay, let's see. Yeah, it doesn't require a meeting password, so I'm not sure what's going on. Video for participants is off. Enable join before host automatically. Yeah, I mean, it's unchecked, so I don't know what's going on. Weird. Maybe they're talking about the meeting ID. Okay, let me also just suggest that. And then we can continue. Okay. Cool, sorry about that. Oh, you only needed the ID. Okay. Yeah, I think you can join with the ID or the link. Yeah, sorry about that, guys. I don't know what's going on today. Usually it is, things do go smoother than this. Okay, cool. So let's just refocus. So this is the type the method returns. Okay, so we just want a method that will take in an integer, multiply that integer by itself, and give the result back or return the result to the calling code. So the type it will return, if we multiply an integer by itself, I mean, it's pretty intuitive, but this is a rule in mathematics. If you have any integer x, x times x is also an integer, right? It makes sense. You couldn't take like 8 and multiply it by or take an integer and multiply it by itself and get something that has like a decimal place, right? Like you couldn't multiply 8 by another whole number and end up with like 2.5 or something, like a 0.5, right? So any integer multiplied by an integer will be an integer. Okay, so that's just a rule. But yeah, hopefully you can see that when we take an integer and multiply it by itself, we will be returning an int. There is some other new concepts that we have to talk about on what type a method can be or what type a method can return, but we will talk about those eventually. But there are, like, you could make a method that returns a string, So that would be like words and stuff. You could make a method that returns a char, so like a single character. A method that returns a bool would be fine. A method that returns a double, so that would be a number with a decimal place. You could do that. Any of the types we've seen. Function name, this can be pretty much whatever you want, but spaces are not allowed, and it cannot start with a special character. Okay, because we know that special characters are reserved, right? These are operators. So the name, in general, a good practice to follow is that your method should, just have, it should just be like a single word that is not reserved. Okay, so to explain that, the word public has a meaning in C#, right? You can see it's highlighted in purple. Calling my method public is not allowed because public already has a meaning. So when I say public here, C# doesn't see that as the name of my function. So the name shouldn't be reserved, but otherwise you can call it whatever you want. You could call it foo, you could call it function, meth, like for method, or method, whatever. You can call it whatever you want. I'm just going to keep mine simple or explicit rather, and I'll say power to or something like that. Okay, so that's my, okay. So this is just a method that will, so you'll say power to 9 and it will return 81. Power to 8 and it will return 64. So it's a method that will raise something to the power of 2. So basically this is just very explicit, right? It's telling you what the function will do. Okay. What does my function expect? Now it can expect more than one thing. Okay, but basically what I need here, so let me explain it like this. So what it needs here is it needs the type of all the variables that it expects. So in my case, my function for now only expects a single integer, right? You give it an integer and it will give you back that integer times by itself, okay? However, the function also needs to know, and this is for itself, okay? The function also needs to know what it will call that integer, okay? Because the integer needs a name, right? So my function could call the integer a, it could call it x, it could call it num. You could be very explicit. You could say num underscore 2 underscore raise. Okay, so num underscore raise to the power of 2. You could go totally crazy, but obviously you want to keep it short because you want to be able to type it very quickly. So I'm just going to call mine int a. So what this is saying is this function expects you to give it a single integer called a. All right, and it will call it a. So the integer outside the function does not have to be called a. So I can say like power to just 9. Okay, so that is an integer. 9 is an integer, and so I give power to a single integer. Power 2 will call it a. All right. So this is the name that the function gives it. It doesn't have to have that name outside of the function. So to put it another way, out here I could create int x equals 9, and I can give power to x. Right? So here the variable is called x. What matters is that it is an integer, right? Power 2 expects one integer, and we gave it one integer. Inside power 2, that integer is called a. All right. And lastly, because I return an integer, so I have to say something like return, and afterwards it must be an integer. Okay, I have to return an integer, something of type int. The computer won't enforce like really anything more than that, right? I could just return 0, right? So you could see if I run that, it just prints out 0. Because what happened there, we said int x equals 9, console.writeLine, power 2. So we went to this method. It expects to get an int back. When the computer comes to power 2, it expects to be given an integer, and it gives in an integer, right? So it expects an integer to be returned, and it gives an integer. And in this case, it gave the integer x, which is 9. 9 was saved into a. We come into the method and we just return 0. So this power 2x just became 0. And so when we console.writeLine it, we just print out 0. Okay, hopefully B has managed to join. Looks like they haven't yet. Weird. Your online meetings can't. I'll help them out during our small break though. Okay, so hopefully we're following. Hopefully we follow that. We could also just return A, right? A is an integer, right? So this would just print out 9 now because it takes in X, which is 9, saves X in A, so A is 9, and then we just say return A, which is 9. So that just, but what we return has to be an integer, right? Because we can't say return dog, right? This is now a string because we can see it's in quotation marks. And so when I run this, it says cannot implicitly convert type string to int. So what's happening there? This expects to get an int back. We gave it a string. So what C# tried to do is it tried to convert the string we gave it, dog, into an integer, right? So it tried to read dog as like 9 or 6 or something, but it can't do that, obviously. So it gave us this error, right? If I made it so that this returns a string, then now it'll be fine. It'll just print out dog. Okay, because now it expects it to get a string back. Okay. Cool. So let's just complete the function as we wanted to. So I'll just say A times A. So it takes in X, saves it in A, and then, or takes in whatever integer you give it. Remember, it can be anything, any integer. Doesn't have to be X. Takes it in, saves it in A, and then returns A times A. And so when we run it, we get 81. Okay, because X was 9. If I changed X to 3, we would get 9. If I changed X to 4, we would get 16. If I changed it to 5, we would get 25, okay, etc. So this is doing what we expect. It takes in an integer, raises it to the power of 2, and returns the answer to wherever you called the method. Okay, so we called it here, and so that's where the answer was put. All right. The number of integers also matters. So like if I try to pass in x comma x or x comma 6, so this is giving it 2 integers, it only expects 1 integer. So you'll see when we run this, we get an error. So no overload for method power 2 takes 2 arguments. So this is just saying power 2, the method, does not take 2 arguments, right? So power 2 takes in a singular argument, int A, and we tried to pass it 2 arguments, x and 6. So that was too many, all right? So yeah, that's also enforced. One special thing we have to talk about. So if you look at our main method on this line, it's public static void main, right? So the type here, because remember what we said, we have like public static, we have the type, we have the name of the function, and we have the things it expects. So this expects an array of strings, if you guys recall, and it calls that array of strings args. We'll discuss what this does eventually. But the point is the main method returns void. So what does that mean? Well, the word void obviously has an English meaning as well. It's like nothingness, right? And so a method can do that. If you say void, we'll see when I run this, it says, since program.power2int, so that's referring to our little function here, returns void, a return keyword must not be followed by an expression, let's say. So this is saying, we say return A times A. A times A is an integer, right? That returns an integer, this bit here, okay? Since power 2 now returns a void, it mustn't return anything, basically. It must return nothing, all right? So let me explain it like this. So I'll comment this out because that's also gonna cause problems. So I'll say power 2. Okay. So power 2 used to return an int, right? Now it returns nothing. Okay, so like I don't even need to put the word return here, and that's totally fine. All right, so if you want a method that doesn't return anything, you say void. Okay, when might that be useful? Well, in this case, you could just print out, so you can say console.write a times a. So now instead of returning the results, instead of returning a times a, I now actually print out a times a inside power 2. Okay, so I don't have to return anything. So the method does all of the work, basically. So it doesn't give back anything. All right. So yeah, this is just the other thing to understand, is that you can make a method void if you wanted to return nothing. Okay, if you wanted to return nothing. Sorry, I do have to, okay, cool. Managed to join, welcome. Sorry, there's lots of trouble today. I'm not sure, not the most. I think a lot of people are also having like load shedding or something, which is not great. Bit chaotic today. But it's all right as long as the lectures are recorded. There's always time to catch up and stuff. Okay, cool. So that's methods really. So the main thing you must know is that before the method name, we tell the computer what it expects to return, and we give the method name, what the method expects you to give it, and then you have to return something of the type the computer expects. Okay, you can see this. So in the kata, so for those of you who were here and stuff, we did this sum of positive kata last week. So you can see that this is true in codewars as well, right? So here we have public static int. So this expects you to return an int, right? This kata wanted you to sum up all of the positive numbers in an array of integers. So given 1 minus 4, 7, 12, you return 1 plus 7 plus 12, so you return 20. 20 is an integer, right? So this positive sum kata expects you to give it back an integer, right? So you return an integer. It also takes in an array of integers, okay? So we know how to show an array. You put the square brackets after the type and you give it the name. So this takes in an array of integers as well. So you can see that this is true on codewars as well. So just by looking at the method that you're asked to program in, so the kata, just by looking at the method that you're asked to create, you can see sort of what solution it expects, what you're given, etc. Okay, so this is all done with methods as we explained today. Okay, cool. So that's the first part. It is quite a lot of new stuff. If you're new, then it might be a bit difficult to take that all in, but I imagine it will become clearer after you revise what we've already covered, just by either reading the textbook or watching the previous lectures. But the next thing I wanted to do is actually revision, just so that we revise this topic before we move into recursion. So I think let's finish this revision before the break. We'll take a break. I'll try to figure out what's going on with the other students, and then we can continue. So last week we discussed a bunch of different repetition structures, right? Like the do while loop, for example, was just a loop that checks the condition at the end, just as an example. We covered 4 different repetition structures. They were the while loop, the do while loop, the for loop, and the for each loop. Okay, so quite a lot of new stuff last week. But we had this sort of, we went through this part where we discussed the important parts of the loop. So this first line was denoting the start of the loop. We have a loop condition, which denotes when the loop stops. And we had a loop increment, right? So initialization, condition, increments. If you understand those 3 components of the loop, you will understand the loop, right? Because the red int iterator equals 0, so that's just creating a variable that's set to 0. That's where the loop starts. It starts at 0. While iterator is less than 3, so that's checking the condition. So while this number is less than the number 3, this will continue running. So it'll go over again, like it'll take another step. Iterator equals iterator plus 1. So this is just saying how large our step is. We are incrementing by 1 each time. So that's saying we're taking a step 1 forwards into the future. Okay, so that's just a reminder of how that was working. The for loop was just a special kind of loop that put all of these in like really neat places, right? It had the initialization, the condition, and the increment. Okay, initialization, condition, increment. If you don't know why I'm reminding you guys of this, you'll see soon. So I'm just reminding you of a loop to set up for what we'll be covering later. Okay, so we could see that this while loop on the left could be translated into the for loop on the right just by saying the initialization at the beginning, so int I equals 0. So that's where the for loop starts. Let me rather draw it. So this is where our for loop starts. This is where our for loop stops, and we go up by 1 each time. If you guys remember, I plus plus is the same as I equals I plus 1, right? So it's just adding 1 to I at each step. Okay. Cool. So in order to just set this up, I need to sort of introduce you guys to maybe a new topic. You might have heard about it before in like high school maths or something. But I'm going to remind you guys about it pretty exhaustively before we move on. Let me just see what time it is here. Okay. So this idea is called a factorial. I'll remind you of it, then we'll take a quick break because I know we've been moving a bit fast and there is some other stuff to arrange currently. So we have this idea called a factorial, okay? And we denote a factorial with an exclamation point. So if you say like five exclamation points, you pronounce that 5 factorial, okay? So 5 factorial. A 5 factorial. So all this is saying is that you multiply the number sort of downwards. Like they sometimes use this idea of like you're descending, okay? So we say 5 times 5 minus 1, which is 4, times by 4 minus 1, which is 3, times by 3 minus 1, which is 2, times by 1, which times by 2 minus 1, which is 1. Okay, so 5 times 4 times 3 times 2 times 1. It's not super difficult to understand on the face of it, right? So you're just sort of going downwards through all of the numbers. So you can imagine 6 factorial would just be 6 times 5 times 4 times 3 times 2 times 1. 3 factorial would just be 3 times 2 times 1, right? So that's just to remind you of this little idea. It's quite a neat idea. In this case, the answer would be 120, if you're interested. So how did we get that? 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is 120. You can kind of always ignore the 1 because obviously it won't be changing anything, right? Because anything times by 1 is itself. Okay. So yeah, just to go through some examples, 4 factorial is 4 times 3 times 2 times 1. So 4 times 3, that's 12, times 2 is 24, times 1 is 24. So that would be 24. 3 factorial, 3 times 2 is 6, times 1 is 6. So the answer to 3 factorial would be 6. 2 factorial, 2 times 1 is 2. And then we obviously have 1 factorial, which is just 1, just by definition. By the way, there's also this little bit here. 0 factorial is 1. Okay, so that's just a special silly rule that mathematicians made up, basically. There is quite a neat reason for it, but I don't know. I'll send a YouTube video that explains it quite nicely. But basically, it's just a rule you have to remember. So 0 factorial is by definition 1. Okay. So there's quite a neat idea here that we can use to make this easier. But before we look at that, I'm gonna make us do it in like a for loop kind of way. But I think we should probably take our break first and come back to that. So let's come back at 10. I'll try to figure out what's going on with the group and see why the rest of us yeah, I'll see why people aren't able to join. I see that there is load shedding happening. I guess we'll just have to plan for this kind of thing in the future from now on. But yeah, let me just try to arrange this. We'll be on break until 10, and then we'll come back and conclude chapter 1. Really a pity about this load shedding thing. Okay. Yeah, so it is because of load shedding. I'm gonna go and grab some water quick. If you guys have any questions about, I'm sure there are a lot of questions, but if you have any pressing questions, feel free to post them in the chat while I'm gone and stuff, and can answer them. So Arthur, have you seen this load shedding thing? Going to be a bit annoying if that's, oh, all the way in the Eastern Cape. Because you see there's no load shedding scheduled in Johannesburg. So I had absolutely no knowledge of this. But if lots of people aren't even in Gauteng, then that makes sense why I hadn't heard about this. Oh, hopefully the load shedding stops. That's a real pain though. I think we might have to redo this lecture for the students who missed it. Maybe sometime during the week or something in the evening. Because yeah, quite a lot of students missed. I think like only slightly under 1/2 of the students who are usually here are here. That's a real pity. Load shedding always coming at the worst time. That will be very difficult to keep track of. Suppose can just add all the students like locations to Escom push or something, but that's probably not the correct way. Because there's obviously way too many students, so adding all the zones would not be a good solution. So yeah, I think we must try to set up like a way to get notified when some students have or expect load shedding. But the best solution is for load shedding to just stop. Okay, cool. It is 10 o'clock. Are you guys back? Can I continue? Or is everyone here? Are we all ready? Okay, I'm gonna get started. Can someone respond, please? I think it's a. Okay, another person joined, so that's good. Okay, cool. Cool. I'm gonna get started again. Okay, so cool. Let's sort of pretend that we want to program this sort of idea of factorials inside C#. And we'll see that there are multiple ways to go about this process. So one obvious way is a loop, right? We've seen loops that count up from sort of 0 to some higher number. And the opposite is also possible. We can make a loop that counts down from a number to a higher number. So I'm going to do this inside a method, all right? So let me make my Rex tester full screen. There we go. And we'll say public static void factorial, or I'll say this will return an integer factorial, and it will take in an integer, which I'm going to call n. All right, so this is the same as the previous methods we've seen. This method is called fact for factorial. It returns an integer, and it expects you to give one integer. And I'll put a little comment here. So for new people, // is called a comment. And all that's saying is whatever's after that comment on that line, you'll see will be highlighted in green. And that is not read as code. It is just like a little comment to explain what's going on to another programmer or to your future self, because you'll often find you come back to code after a couple of weeks and you don't know what's going on. So you put comments just to explain things when you need to. So here we'll put // and I'm just going to say returns n factorial. Okay, something like that. Sorry about the background noise. I know there's a lot today. Today is a bit of a mess up. Okay, so cool. So what we need to do, this n factorial just equals n times by n minus 1 times by n minus 2. And we just sort of keep going, right? So ... And we go down until we get to times 1, right? Times 1. So that's what n factorial is. So we just need to program something that does this, okay? I think probably the easiest way for us to go about this is with a while loop, actually, because I think that's probably the easiest to visualize since we went through it line by line. So let's try that out. Okay. In general, you would use a for loop because the initialization and everything is on the same line. But let's just try with the while loop so we can see. Okay. So how we'll do this? We'll set int I equals n. Okay, int I equals n. So. So this is just saying where our loop will start. I'm going to do it in a very traditional way. Of course, you could just use n, right? You could just use n itself, rather than creating a new variable I. But just to make it look a lot like the other while loops we've seen, I'm going to do it this way. So for now, the first thing I want to do, we can see that we've got this process of counting down, right? So we go n minus 1, n minus 2 to 1. So I want a while loop. To start, I want a while loop that counts down from n to 1. Okay, so let's start by creating that. So this while loop, we'll say while. Okay, and I put out the entire sort of structure, right? So while with normal brackets, followed by curly brackets. And we say while I is greater than 0. Right, so while I is greater than 0. Okay, so which numbers you can picture this in your head, I'm sure. The numbers that are greater than 0 and less than n, or less than or equal to n, are the ones that we are looking for. So I'm just going to say console.writeLine I. So just print out I at each step, and then just say I equals I minus 1. Okay, something like that. So when I run this, sorry about that. I need to obviously call it. Okay, so we're in a method called fact. You can see in main, we're still calling power2, so that's obviously going to cause problems. Since I'm not yet returning anything, I'm still building the method. I'm just going to make this void for now. Okay, so it doesn't return anything. And I'm just going to call fact on, let's say 6. So I expect this to go 6, 5, 4, 3, 2, 1. Okay, that's the goal. That's the goal. So when I run this, you can see it goes 6, 5, 4, 3, 2, 1. And whatever number I give it, it's just going to count down. So if I give it 9, it'll go 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. So hopefully from our previous discussion of for loops, and of while loops and just repetition structures in general, you understand what's going on here, right? So it's just that our initialization, previously we've seen it equals 0. We've also seen loops where it was 1. This time it's n. Usually where we stop is while I is less than some higher number. But now we're just going until I gets down to that number. And at each step, we just subtract 1. Okay, so I think that's a pretty okay thing to visualize. I also want to show you that we can do this. We can do this in a for loop as well, right? So maybe let's show that. So we could say for int I equals n. It will require some slight changes, but hopefully you guys will be able to see. So I greater than 0. So we've just moved this thing over here inside the for loop. So it's now inside the for loop for int I equals n, while I is greater than 0, and then we just say I equals I minus 1, like so. Okay, and we no longer have to subtract 1 here. So that's how you would do it in a for loop. So you can just see it's our initialization, our condition, and our increment. Okay, or in this case, decrements, I suppose, because we're going downwards. Okay. And yeah, so this still just counts down, 9, 8, 7, 6, 5, 4, 3, 2, 1. So that's doing the exact same thing that our while loop did. All right. So that was just a revisor of loops. So we've created something that can count down. We now need to, so all this will do is it'll run over and it'll count down. We've seen this a few times now. All we need to do now is multiply those numbers by each other, right? We just need to multiply those numbers by each other. So I'm just going to start by saying int, okay, int answer equals 1. All right. So maybe there's a easier way to explain it. I'll do it this way. I'll start answer at n, and I'll start our loop at -1. Okay, and then I'm going to say n equals n times I. Okay, might look a little bit hectic. I'm also going to print out I so we can see what is going on here at each step. Okay, so let me do that. Okay, so let's see. So when I run this, okay, you can see that I is now counting down from 8 because it just starts at n minus 1, right? So whatever I make n, so let me make n 5. You can see that it just counts down now from 4, 3, 2, 1. The reason that's okay is because n now starts at 5. So if we picture step by step, so let's run this through step by step. N starts at 5, so we say int answer equals n. So answer is currently 5. So answer is initially 5. We start the for loop. I is initially 4. Okay, we check 4 is greater than 0, right? 4 is greater than 0, so we run. Okay, answer equals answer, which is 5, times by I, which is 4. Okay, and then we print out I just to see that it's 4. So answer becomes 5 times by 4, which is 20, right? So answer becomes 20. Good stuff. We then subtract 1 from I, so I is now 3. Okay, we check again. 3 is greater than 0, right? 3 is greater than 0, so that's true. And so we run again. Answer, which is currently 20, equals answer, so 20 times by I, which is 3. So we get 60, right? So answer becomes 60. We print out I just to make sure, so I is 3. We subtract 1 from I, so I becomes 2. 2 is greater than 0, right? So we say answer, which is now 60, equals answer times by 2. So it's now 120. Okay, we print out 2 just to make sure. We subtract 1. I is greater than 0, it's 1. Answer equals answer, which is 120, times by I, which is 1. We print out 1. We subtract 1 from I, so I becomes 0. Is 0 greater than 0? No. So we stop. Okay. So ideally, in this case, when I print out answer, or not print, when I say console.writeLine answer, we will get 120. Okay, because it went through, it basically did this process on the first line. It said 5, because that's where answer started, times by 4, which is what I was on the first step. On the second step, I was 3. On the third step, I was 2. On the last step, I was 1, and then it stopped. Okay, so we got 5 times 4 times 3 times 2 times 1, which should be 120. So when I run this, you can see at the end we have 120. Okay, so we just programmed this idea of a factorial. Okay, makes sense. So hopefully you guys understood that, and maybe it was a good way to draw together our knowledge of for loops and loops in general and repetition structures. So you can see we can count down or we can go up. That's what I wanted this example to show. All right. Cool. But there is a cleverer way to do this. So also, instead of printing out answer, I'm now going to say it returns an integer, and we're instead just going to return answer. Okay, return answer. Okay. So that's a method that calculates a factorial using a for loop. Okay. But there is a cleverer way to do this. So in order to see that cleverer way, we're going to have to we're going to have to search for a little pattern here. Okay, we're going to have to search for a little pattern. And the best way to find this pattern is to start at the bottom. Okay, is to start at the bottom. Okay, so 1 factorial is 1. Remember, 0 factorial is defined as 1, right? So 1 factorial equals 1 times 0 factorial. So we get that, right? What is the answer here? This equals 1. Correct, so let's do that. This equals 1. Right? This equals 1. So let's start by thinking about that. And now let's move upwards. So 2 factorial equals 2 times 1. Okay, 2 factorial equals 2 times 1. Well, we know where 1 can come from, right? 1 is over here, right? And that 1 is equal to 1 factorial. Okay, can you see that? So instead of saying 1 here, we can say 1 factorial. Okay. Cool. So 2 factorial equals 2 times 1 factorial, because 1 factorial is just 1. So 2 factorial equals 2, right? Equals 2. But the other thing you can see is that this is 2 times by 1. Okay, 2 times by 1. We just saw, so this by definition is what 2 factorial is. Okay. We can see that 2 factorial is equal to 2 times 1 factorial. Okay. So we can replace that with 2 factorial. So 3 factorial equals 3 times 2 factorial. Okay. And you can keep going up. Hopefully you can sort of extrapolate this pattern up. So we can see that 4 factorial equals 4 times 3 times 2 times 1. Well, 3 times 2 times 2 times 1 is just 3 factorial, right? So 4 factorial equals 4 times 3 factorial. And you can see up here that 5 factorial equals 5 times 4 times 3 times 2 times 1. But 4 times 3 times 2 times 1 is by definition 4 factorial, right? And so, yeah, 5 factorial equals 5 times 4 factorial. Now, I'm sure, as you can imagine, 6 factorial equals 6 times 5 factorial. 7 factorial equals 7 times 6 factorial, etc. So I want you guys to see this pattern emerging. Okay. It turns out we can use this pattern to write the code that we just wrote in a much easier way. Okay. So you can see we've got this whole for loop going on, right? We've got this for loop that counts down from n. There is a faster way to do this called recursion. Okay, recursion is like a bit of a magic trick in programming. It's a very powerful idea that can help you do pretty complex tasks. I think other people are going to be switching off load shedding now as well, since it's 10:30 almost. Recursion is a very powerful idea in programming. It can help you do a lot of complex tasks. So yeah, the basic idea is that the method will call itself. So let me explain it in drawing as well, since that I know helps some people. Make this full screen. So you can see when we want to calculate 5 factorial, right? When we want to calculate 5 factorial, the best way to do it, or a good way to do it, an intuitive way, is to say that we have the number 5, right? We're given the number 5. We're asked to calculate 5 factorial, okay? So we take 5 and we multiply it by whatever 4 factorial is. Okay, so we just have to go and calculate 4 factorial, which might be easier. So let's go check that out. How do we calculate 4 factorial? Well, we take the number 4 and we multiply it by 3 factorial. Okay, so how do we calculate 3 factorial? Well, let's go check that out. Maybe there's an easier way to do it. So when we're calculating 3 factorial, all we're going to do is take the number 3 and we're going to multiply it by 2 factorial. Okay, so how do we calculate 2 factorial? Well, we'll go down here and we'll see how we calculate 2 factorial. So 2 factorial equals 2, so we'll take the number 2 and we'll multiply it by 1 factorial. Okay. Well, 1 factorial, and we could go down, right? 1 factorial equals 1 times 0 factorial, but hopefully we could already stop here, right? 1 factorial equals 1. Okay, so I know now that 2 factorial equals 2 times 1. Okay, it equals 2 times 1. And we can basically pass that back up. So this is 2. We now know that this is 2. So this is 3 times 2. So this was 6. This is 4 times 6. So this was 20. And 5 times 20 is 120. Okay. So it turns out we can use this idea in programming, right? Basically, if we can create a method that can solve 1 factorial. So it literally just says, if n equals 1, return 1. If we can do that, then we can find any factorial, right, using this pattern. Okay. So let's just try it out, okay, just to really show what we're doing. Okay, so instead of this factorial method I have here, I'm going to remove this, all right? Well, first I'll say console.writeLine. So I'm going to print out whatever factorial, whatever our method here returns. So you can see currently it returns answer, which was 120. We were calculating the factorial in the silly way, okay, using a for loop. All right. I'm now going to use a recursive method. So I'm going to make a method that calls itself. All right. I think the easiest way is for me to sort of write it out and then explain the logic through that. So what we need, firstly, is to ask the question, is what I am solving for 1? So am I given 1 factorial? If I am, then I'm just going to respond 1. Okay. So let me translate that into the code, and you'll see how that works, and hopefully it'll make sense. So this is given an integer called n. So I'll just ask the question, if n equals 1. So is n 1? Am I calculating the factorial of 1? If I am just going to return 1, right? I know the answer. Okay. And let's say otherwise I'm going to return 0 for now. Okay. So what would this do? Well, if I ask it for the factorial of 1, okay, like that, and I run it. So I ask fact1, you can see that it returns 1. So that works. Okay. It now calculates 1 factorial. If I ask it for 2, it will return 0. If I ask it for 3, it will return 0. If I ask it for any number that's not 1, it's going to return 0. So it's not ideal yet, obviously, but we can see that we can do this bottom piece. Okay, we can calculate 1 factorial. Cool. So we can calculate 1 factorial. So how would we go about calculating 2? Well, we could see that if we're given 2, the answer is 2 times by 1 factorial, right? So we can calculate 2. So I can show you how you might think about doing this. So, but this is true for anything, right? So if whatever we're given, like if we say 5, the solution to that is 5, so the number we were given, times by the factorial of 5 minus 1, right? 4 factorial, so 5 minus 1 factorial. If we were given 4, the solution is 4 minus 1 factorial. If we were given 3, the solution is 3 minus 1 factorial. And if we were given 2, the solution is 2 minus 1 factorial, which is 1. So we already know the answer for that. That's fixed. Okay. So in all other cases, let me show you, and it might be, hopefully it's a little bit mind-blowing. So in all other cases, so if n equals 1, we'll return 1. In all other cases, we are going to return n times by fact of n minus 1. Okay. So you see I call factorial there. So I'm inside factorial, and I call factorial on n minus 1. So the method is calling itself, and we call that recursion. And you'll see now that this works for any number you give it. If I give it 5, it will return 120. If I give it 6, it'll return, I think, 720. Yeah. So it will now calculate any factorials successfully. Okay. Which is quite an impressive thing, I think. So yeah, you can see we're just exploiting that pattern that we saw. So we say n times by fact of n minus 1. So let's picture what is happening here for 3. Okay, and we can draw it out. Okay. So we can see 3 returns 6. Okay, 3 returns 6. So we say fact of 3. All right, so it comes over to fact, and it gives it 3. Okay, so fact checks. Is 3 equal to 1? No, it's not. So it continues, and it comes over here. All right, it then decides that for 3, it's going to return, oh, it's handwriting. For 3, it's going to return 3 times by fact of 2. Okay, fact of 2. So it calls fact of 2 again. Let me just type it. It's going to call fact of 2. Okay, like so. So what happens when it calls fact of 2? Well, it goes back into the method. So it knows where fact is, right? Fact is up here. So it goes over it again, and it gives it 2 this time. So it checks, is n equal to 2? No, it's not. So what will it do? It'll go again, and this time it's going to return 2 times by fact of 1. Okay, so this time it'll be fact of 1. Fact of 1. Okay. Then what will happen? Well, it knows where fact is, so it goes up to fact, it gives it 1, and it asks the question, is n equal to 1? Okay, it is. So now it returns 1. So what happens there? Well, this fact of 1 is deleted. It's replaced with 1, right? So that's 2 times 1. But remember, this call, this question was asked, this question of what was 2 factorial was asked over here, right? Up here. So fact 2 is now 2 times 1. So that's replaced with just 2. But this question over here was being asked by fact 3. So that's just 3 times 2. And so this just becomes 6. All right, fact 3 just becomes 6. Okay. So that's what's happening there. You're creating like, it's calling itself and then calling itself again and calling itself again and like moving downwards until it gets to 1, at which point it stops, right? It stops calling itself and sees that it's 1. And that's called recursion. Okay, quite a powerful idea. Can be somewhat difficult to get across, but I hope I've explained it adequately. In general, are you guys okay with this? Can you give me some idea? Are you understanding this concept? Anyone? Are you guys comfortable with that? Because it can be your okay, kind of. All right. I think that's a fairly good start, and there are some katas that can help it get across even better, I think, when you see it for yourself in like other ways. Okay. But the main thing, since in the course itself, you're mainly asked about when to use these ideas and sort of what they define. So the main thing to take away from this is that this is a method that is calling itself. Okay. It is a method in C# that is calling itself. And what we call that, the word we describe that with, is recursion. Okay. So that's the main thing to take away, really, without understanding the full sort of flow. Okay. But this is an easy way to break things. So even if you try it on like on a fancy scientific calculator, you can see that these numbers get huge very quickly, right? So we can say fact 4 is 24, right? Fairly small. Fact 5 is 120, also fairly small. Fact 6, 720, getting a bit crazy now. Fact 7, like 5,040, getting very hectic. Fact 8 is 40,320. So they get large very quickly, right? And as soon as we go to fact 9, we're up to like 360 odd thousand, right? Do you guys remember what the largest number an integer can hold is in C#? Or around? You don't have to give it to me exactly. You would find it on page 9 of the textbook, though. I'll wait until someone. Yeah, exactly. It's around 2.1 billion, right? So we're already at 362,000. So you can imagine like fact 10 is now 3.6 million or something. Fact 11 is getting too large to really think about. Fact 12, also getting quite crazy. Fact 13. But very quickly, we'll get to a point where things start to break. Like already, these answers are no longer correct soon. So we're at now 2 billion. 16. Yeah, we're we're around the breaking point here. You see it became negative. What is going on there? So what just happened? It became negative. Very strange, right? So the thing is that because we're holding this in integers, integers hold minus 2.1 billion to plus 2.1 billion. Okay, around that. So let me display this in a very specific way that can maybe show it better. I haven't done this before, and live demonstration is always dangerous. But let's see if this works. So I'll be exact about it. I'm going to create an integer called x that is called 2147483 Okay, so that is the largest integer C# can hold. All right. So let me say console.writeLine x. Okay, that is the largest integer C# can hold. Okay, you can see when I try to add 1 to that, let me add 1 in a different place actually, because it might not evaluate correctly then. That would be quite cool. Yeah, so you see when I add 1 to it, it became minus 2.1 billion 483,648, which is the smallest integer C# can hold. Okay. And see if I add 2, it will just change that to a 7. Okay. So what we call this is integer overflow. Okay. We call this integer overflow. So, oh, sorry, I should sort of send that to everyone. Call this integer overflow. So we were at this positive number, but as soon as we add 1, it ticked over and went all the way back to the other side of the number line. Okay. So quite an interesting idea. But what I just wanted to show is that errors can happen. Okay? So there are times when we're not certain about how things will operate, right? Like where things don't operate in a strictly logical way. So we can say, or rather it is logical, but it's just not, it's perhaps not how you would expect things to work, right? So there are times where our code will produce errors and we need to correct those errors. You can see if I ask for fact 400, it just returns 0. Okay. And so this was just as a way for me to tie in this part of recursion into the final section of chapter 1 before we can get onto the more fun abstract stuff. Okay. For now, what I'm going to do is save this Rex tester code. So I'll say this is the MTA Saturday recursion or factorial recursion. And just click OK on that. Okay, so if you visit that link, you'll be able to see and play with the code yourself. You can click in the bottom right, there'll be a button that says fork it. And if you click that, you can create your own copy of it on your Rex tester account and edit it and save it and do whatever you want with it. So yeah, if you ever want to access this code and play with this idea of recursion, you now can. But the final topic we would be covering in chapter 1 is called the try-catch statement. But actually, so this is a way that we can handle exceptions, handle errors in a strict logical way. Okay. Before we get onto that, though, I do just want to test out this idea. So, I mean, just go through these katas. So the sum of positive kata. Oh, for the new students, this website is called codewars.com. you should definitely create an account on it. So if you, I'll just sign out to show you how. So when you arrive on the codewars homepage for the first time, and if you don't have an account, you'll see this, right? So you pick a language that you want to join with. We're using C#, so click on C#, and you have to complete this little initiation challenge. I'll leave it to you to try. I'll say that it's this initiation challenge, so you take in 2 integers, and you're expected to multiply them together. Just from our discussion of methods this morning, I think you should be able to solve this initiation challenge, or at least try to. And if you want some assistance, feel free to WhatsApp me. Okay, but do solve the initiation challenge. After you do, you'll be able to log into codewars. Okay, and so yeah, you can just log in when it eventually does log in. I think I can use my GitHub actually. Okay, so once you log into codewars, you'll get this. If you go to account settings, there'll be a section called clan, company, school, organization. So on the top right, you can click account settings. You'll be brought here. If you make your clan brighter futures, capital B, capital F, space in between, exactly like I have it written there. So you make your clan brighter futures, you scroll down and click update. Then you'll automatically join our clan, so we'll be able to see what we're up to. Okay. Cool. So here is the clan currently. I can see some people have solved the sum of positive thing, it looks like. I can just check. How do I look for this? Okay, it does work. All right, cool. It's quite a nice thing. So yeah, so some people have solved the katas so far, so that's cool. We've only done 1 kata so far, and that's the sum of positive kata. So I'll just use this to show you guys the general idea, and yeah, so we can discuss things. So this is what a kata looks like. They'll give you some instructions on the left. So in this one, they say you get an array of numbers, return the sum of all the positive ones. Okay, so they give you a little example here. We get 1 minus 4, 7, 12, and we're supposed to return 1 plus 7 plus 12, which is 20. Okay, note if there's nothing to sum, the sum is default to 0. Okay, so how do we do this? Well, we'll say int sum equals 0, right? We need a variable to hold the sum of all of the positive integers. We'll make a for loop or for each loop that goes over the array. Okay, so the easiest way is to use a for each loop. So we say for each int num in R. Okay, something like that. And we'll say sum equals sum plus num. So that's adding up all of the numbers inside our array R. And at the end, we'll just go ahead and return sum. Okay, so after we feel like we've solved a kata like this, we would click test in the bottom right. And on the left here, they'll run some test cases. Ooh, I actually failed the test. So what went on here? You can see I added all of the numbers, right? So I added num to sum. And the goal was to add positive numbers. So I need to add a little check to check if a number is positive. We'll do that with an if statement, which is something we covered in our first lecture. So I'll say, if num is greater than 0, then I'll add it. And now when I run test again, you can see that all of the tests passed. So it says you have passed all of the tests. Once you've passed all of the tests, you can go to the bottom right and click attempt. They'll run another batch of hidden tests, more difficult tests. And you can see in this case, they ran 45 different tests. I passed every single one. And so I can click submit. And there we go. The kata is complete. Okay, so that's how an individual kata works. Each week, I'll recommend a kata relevant to what we've learned in the most recent lecture. For this week, there is a 7Q kata. So how we'll do this, you'll come to this page called kata. So you'll go to the left, click kata over here. You can filter by difficulty. So 8Q is the easiest, 1Q is the most difficult, and it just goes up by 1. So the kata we'll be doing this week is called 7Q. If you go here and you type recursion filtering by 7Q, there is this kata called recursion number 1 factorial. This kata, you basically just do what we did today. So in mathematics, the factorial of a non-negative integer n denoted by n factorial is the product of all positive integers less than or equal to n. For example, 5 factorial equals 5 times 4 times 3 times 2 times 1, which is 120. The value of 0 factorial is 1. Your task, you have to create the function factorial that receives n and returns n factorial. You have to use recursion. Okay, so they give you a little method here, and you just have to fill it in. All right. And they tell you you must write your code in this area. Okay, so where the comment is, write whatever your recursion code is right here. Okay, whatever code, it'll be very similar to the code that we wrote in the method that we just saw now, and we'll review it next week. Okay, so that is the kata for this week. If you finish that one and you want more of a challenge that's more new, okay, a recursion problem that you haven't seen before, on the same kata, in the instructions, they have this link to next recursion number 2 Fibonacci. So if you click that, you'll be brought to another slightly more difficult recursion problem. It is similar though. Okay, it is similar. So you could try that out if you want as well. And I'll discuss them next week. Okay, I'll also discuss the Fibonacci one if one of the students manages to finish it. Okay. Cool, so that is Code Wars for this week. Also just an update for the new students, just to make sure everyone's on the same page with Code Wars. Okay. In the last sort of 15 minutes, I want to discuss some of these errors, and just so that we can see that errors do occur in C#, and that C# has some interesting ways of handling them. But I think we'll probably only conclude this discussion of the try-catch statement next week. Also, it's probably best to slow down a bit this week as well, given that so many people missed due to load shedding. Okay. So on the right here of my, on the left of my screen here, I have 5 errors listed out. Okay. These, you can see that the names might look a little bit weird to you. So we have system.index_out_range exception, system.stack_overflow exception, system.divide_by_0 exception, out of memory exception, null reference exception. Okay. Currently, I don't expect you to know what any of these really mean. Initially though, the word exception, okay, is used as a synonym for the word error. Okay. So if you get an exception, it means an error has occurred, something has gone wrong. There was something that C# did not expect to happen that has happened, and C# is just telling you. Okay. Each exception has a different name. Okay, so there's this one's name is index out of range, this one's name is stack overflow, this one's name is divide by 0. Okay, there are a bunch of different names for exceptions. Okay. So obviously, because different errors occur, we've created a lot of different named errors, right? So let's go through this list and see what each of these errors mean, what they correspond to. So perhaps the simplest, the third error here, is system.divide_by_0 exception. System.divide_by_0 exception. So let me show you when that might occur. I'll create int x equals 6. Okay, so that's just me creating an integer variable called x with the value 6. Okay. I'm going to create another integer variable called y, and its value is going to be 0. Int x equals 6, int y equals 0. Now, as you'll see on any calculator, I'll actually open up my calculator over here in Ubuntu. So here I've got a calculator. If I take any number and I try to divide it by 0, you can see that division by 0 is undefined comes up, okay? So division by 0 is not a thing in maths, right? It's just an error. It's a crazy exception. It doesn't make sense, okay? So when we int x equals 6, int y equals 0, let's see if C# has a similar understanding. So I'm going to say console.writeLine, what is the result of saying x divided by y? So x is a placeholder for 6, y is a placeholder for 0. What happens in this case? When I run this, you can see it says errors, exception in user code. So it's saying exception. You see it's using these as synonyms. Okay. System.divide by 0 exception. Attempted to divide by 0 at, and it tells me where I did it, at rextester.program.main. So it's saying in the namespace rextester, in the class called program, in the method called main, we tried to divide by 0. Okay. So you can see C# saw this exception occurred, and it's telling me what went wrong. And it will always do this, right? Like if I leave out a semicolon, it'll tell me that something unexpected is happening, right? It says it expected to see a semicolon and it wasn't there. And when I put the semicolon back, you can see it now tells me that I'm dividing by 0. So C# knows when errors are happening, right? If I made this 1, then nothing would go wrong. It's just printing out 6. Okay. So that's one obvious one, system.divide by 0 exception. That happens when we divide by 0. Okay, so it's a pretty good name. Another one that we can probably easily understand is index out of range exception. Okay, so to show you this one, I'll have to remind you of this idea of an array, right? So here I've got an integer called x that's set to 6. So it's just a single integer. If I want to store an array of integers, like a lot of integers, I want to store a collection of integers, I can simply add some square brackets after the int, right? So int with square brackets, x equals, and now instead of giving it a single integer, I can give it a whole lot of integers. So I can give it 4, 5, 4, 5, 6, 7, 8, right? I can give it as many as I like. Okay, a whole list of integers. You can see here I have 1, 2, 3, 4, 5 integers. And yeah, so I'm gonna save them. I'm gonna call the list nums or numbers, just to be explicit. So I've got an array of numbers. And I'll say numbers in position 0, that will give me 4. Numbers in position 1 will give me 5. Numbers in position 2 will give me 6. Numbers in position 3 will give me 7. Numbers in position 4 will give me 8. Okay, so we start counting at 0. So 0 was 4, 1 is 5, etc. Okay. Now, what happens when I access numbers in position 5? What happens when I access numbers in position 5? So we said that this is 0 is 4, 1 becomes 5, accessing in position 2 becomes 6, index 3 becomes 7, index 4 becomes 8, index 5, well, that seems that it's not really in our array, right? Our array goes to index 4. So when I access index 5, it says errors, exception in user code, system.index out of range exception. Index was outside the bounds of the array at rextester.program.main. So again, it tells me exactly where this error occurred in my code. And I see, yeah, we are accessing index 5. That is outside the bounds of the array. Okay. Similarly, like if I try to access an index -1, index was outside the bounds of the array. Okay. So it's not possible to break out of the bounds of the array. There is like a portion of memory has been assigned for this array. If you try to access outside of that, things will break, and C# will tell you that. And that kind of error is called an index out of range exception. And it makes sense, right? So the range of this array is 0. Range is 0 to 4. Okay, and what do we call this little number? The number that I am attempting to access here, that is called the index. Okay, so 4 is indexed at 0, 5 is indexed at 1, 6 is indexed at 2, 8 is indexed at 4, right? So we can go from 0 to 4 inside this array. That is the range of our array. The other way you can define range has a mathematical definition, right? So it is the largest possible number minus the smallest, which in this case is 4, right? So our range is 4. So if you're trying to access outside of that range, things will break. All right. So yeah, we've got like, so yeah, that makes sense. The name is fairly sensible. It's saying that the index you're attempting to access is outside of the index range of this array. Okay, so that's another error. Another error that we might have an easy time understanding is this null reference exception. You guys have seen the word null before, I think. We did discuss it a little bit. But how we might see this is what happens if I don't define this array, if I just set it to null. Okay, you see null is highlighted in purple. It means like nullified or basically empty. It's just nothing. It's nothingness. Okay, it's not referencing any part of memory. Okay, so when I try to run this now, so numbers is null, and I try to access numbers in position 2, you can see I get an error, exception in user code, system.null reference exception, object reference not set to an instance of an object at rextester.program.main. So again, it tells me exactly where the error occurred. It tells me what error is occurring. So the problem here is that this object, numbers, this object here, is set to null. It doesn't exist. So it is referencing a null thing. It is referencing a null object, an empty, it's referencing emptiness, basically. And so when I try to use it, it just doesn't know what to do, right? It's null. It doesn't correspond to anything, okay? And so it tells me that there is a null reference, okay? So yeah, makes sense. Another fairly sensible error name, right? So this object is not sent to an instance. Yeah, cool. Another fairly sensible name is system.out-of-memory exception, okay? A system.out-of-memory exception would of course run when you run out of memory. So I'm not sure if I can demonstrate this in C# necessarily, although maybe I can try. I mean, in Rextester, sorry, because Rextester I think will stop me before it allows me to break it like that. Yeah, so you see it says process killed because it exceeded given resources. Memory used 104 megabytes. So in trying to create this array, I tried to use 104 megabytes, and Rextester is just like, hell no, you are not allowed using that much of our server's memory. So Rextester stops me. In actual C# on your own computer, so in Visual Studio or in any local editor, obviously it's not going to stop you from trying to use 104 megabytes of your own computer's memory. But eventually, your computer will just run out of memory, right? Your computer has a set amount of memory on your processor. So depending on like if you have what Intel processor or whatever processor you have, it has a certain amount of memory, probably like 4 gigs or something. And if that memory runs out, obviously things will break, right? It can't assign any more memory. And when that occurs, it tells you that you have an out of memory exception. Okay, an out of memory exception. Okay. Yeah, and there are a few. This last exception is slightly more difficult to understand, I think. But it is basically it's to do with recursion. Okay. Again, I think Rextester will probably stop me before. Ooh, sorry about that. I think Rextester will probably stop me before. Look, no, so it didn't. Okay. So you see process is terminated due to Stack Overflow exception. Okay, so this last one has to do with recursion. We'll understand this a little bit more in chapter 4. There is a structure in computer science called the stack. Okay, so the stack is a certain portion of memory reserved. It's like a reserved portion of memory, and it like fills up. Okay, it stacks up, and each time I call foo, or any method, if I call main, if I call foo, if I call function, if I call power2, whatever method I'm calling is added to the stack. You can think about it like a stack of pancakes. So every method you call is added to the stack of pancakes, and it adds up, adds up, adds up. The stack grows and grows and grows. You can see in this case, what I did, I call foo. Let's look at this. So we start in main. I call foo. That goes over here, right? It calls foo. It then executes inside foo, and foo calls foo, which 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 calls foo. And this happens for infinitely, basically, or it happens until our stack gets too big and overflows. And when that occurs, we get what's called a stack overflow exception. Okay, you'll understand this error a little bit better once we discuss data structures later on. But for now, what you must know is when we call functions too much, when our stack gets too full, when we call too many methods, usually recursively, we get what's called a stack overflow exception. Okay, so this is 5 exceptions, 5 errors that can occur inside C#. Okay, there are many more. There are literally thousands of errors defined in all programming languages. There are many of them, many different kinds of errors. We can't possibly go over all of them. I've given you like a sample of 5 of them, explained their names to you. All of them have fairly sensible names. So as you understand more computer science theory, when you come across an exception, you'll be able to understand what it is referring to. But the important final part of chapter 1 here is just understanding how to handle these exceptions. How do we work with them? How do we solve these problems? Okay. There is a specific structure inside C# and many other programming languages called the try-catch finally statement. We don't have time to discuss it in this lecture, but this is the last part of chapter 1, which we will conclude at the beginning of next week. Okay, and that will bring us to the end of chapter 1, which I personally think is it's one of the more intense and the more maybe less interesting portions of the course, because you're just discussing a bunch of simple programming topics. But once we finish these core programming ideas, we can get on to the more interesting, more powerful ideas. So yeah, hopefully the load shedding stops and we can stick through it through chapter 1 and then continue with the more interesting side of chapter 2 and 3. I really like chapter 3 actually. Cool. Thank you for coming, guys. Sorry about all the load shedding problems that happened for those of you who are watching on YouTube, and we will try to account for them more next time. Glad that there was at least a reason for attendance being poor today. But we will try to account for load shedding and all of this kind of stuff more in the future. But yeah, please do, if there's ever going to be like any scheduling conflicts or if there's load shedding happening, please let me know on the WhatsApp group before the lecture, so that we can organize for it, because yeah, I can't keep track of everyone's load shedding zone and things like that. So if there's ever going to be a scheduling conflict, let me know and we can sort of discuss rescheduling perhaps. But the lectures will always be recorded, so at least there's that safety net. Okay. So yeah, thank you for coming today, guys. Sorry it was a little bit chaotic at the beginning. I think it became more okay as we went through it though, I hope. But yeah, there was some disaster management today, I think. But yeah, thank you guys for coming, and see you next weekend. Eh? Yeah, enjoy the rest of your weekends as well. No problem. Thank you for coming.